Alright, hi everyone, how are you doing? So today we have another Codeforces round and it is like a Div1 and a Div2 round. So I'll be attempting Div1 today. And I mean my rating is at its peak right now. So if I perform really well today, I might just reach master. So yeah, that is something I'm aiming for in this particular contest. And I have a little cough and cold, so my voice is not, I mean, it wouldn't be that clear, I think. So yeah, you'll have to bear with that with me. Let's see. So let's begin. Fine, you know who has an integer sequence a1, a2, so on up till an, he will perform the following operation until the sequence becomes empty. Select any index, an index I such that, okay, right, ai is not divisible by, I is less than size of a, and ai is not divisible by I plus 1. Okay, and erase the element from the sequence. Here is the length of the sequence at the moment of operation. Okay. So if we have like 10 elements remaining, then and let's just suppose that only 9 are remaining from in the initial 10 elements, then I can only remove one element from the fine. Note that the sequence A changes and next operation is performed on this changed sequence. So when we have this, then he can select I equals to 2 and A2 equals to 5. Is not divisible. Okay, it shouldn't be divisible by I plus 1. After this operation, the sequence becomes this. Okay. If it is possible to erase the whole sequence. Alright. So AI is now the thing is that for every element I can define certain indices for which this can be removed, right? But how will I choose these indices? That is the question. So if you look at 1, 2, 3, then in the first test case, you know who can perform the following operations. 2 is removed because it is not divisible by 3. Fine. Then I just remove 1, which is not divisible by 2. Then I remove 3, which is not divisible by 2. Oh, I see. So if I just look at the last number that is being removed, then that has to be not, that shouldn't be a multiple of 2. That is for sure. If all the elements are odd, then this is not, if all the elements are even, then this is not possible. If there is one element that is odd, yeah, I mean, for the odd elements, they can be removed every time we have an odd element at an odd index. We can remove that. Right. So an odd element at an odd index can be removed. And for the even elements, we are not sure, like anything can happen here. Now if you talk about element at the 4th index, then it can always be removed unless and until it is a multiple of 5. Right. So any element can be removed unless and until it is a multiple of the next element in line. Right. So are we having submissions on this one already? 25 submissions already. Now if you look at the very first element, then it has to be removed. Yeah, if we just look at the first element, then it will always be removed, right? I mean, the first element cannot be even, that is for sure. So we can remove it at any place we like. Yeah, that is fine. If you look at A2, then if A2 is like, if A2 is a multiple of 3, then we should remove it before A1, right? If A2 is a multiple of 3, we can remove it before A1. And if it is like an odd number. So the second element can be removed at indices at indices 2 and 1. Right. Similarly, for the third element, the third element can be removed at indices 1, 2 and 3. We just have to figure out where do we want to remove it. Right. The first element can be removed with index 1. So it has like one choice only. It shouldn't be a multiple of 2. For the second element, it shouldn't be a multiple of 1 or 2. Right. If it is not a multiple of 2, then I can remove it at that very moment. Similarly, for the third element, it shouldn't be a multiple of, this is 2 and 3. 2, 3 and 4. If any of them works, then I can probably do this. For example, if for the first element, if 1 works, then I pick up 1. I can pick up 2 and 3. For the third element, I can pick up 2, 3 and 4. So I think it is all about the LCM. No, if it is not divisible by any of them, then it works. And if it is divisible by all of them, then it does not work. Right. If ARR at I modulo for LCM equals to 0, then answer equals to false. Right, and here what we do is GCD of no, no, yes, no, no. For the first time having no. If ARRI modulo current LCM equals to 0, this should be I plus 3, right? Yes, yes, no, no. No, but how is this? Oh, this had to be this had to be 0, this had to be I plus 3. Yes, no, yes, yes, no. I think this is fine. Great. So this is fine. Let's move to the next problem. Moderate modular mode, okay. Has two even integers x and y. Help him to find an integer n such that n is in this range, 2 into 10 to the power 18, and n modulo x equals to y modulo n. Oh, okay. Here a modulo b denotes the remainder of, okay, fine. Output any. Okay. It can be shown that the answer always exists under the given constraints. Okay, so what do we want here? We want n modulo x to be equal to y modulo n, okay. We want n modulo, okay, let me make another page here, should be equal to y modulo n. Okay, let's look at this. So let's say this value is equal to k, then we have n equals to x times something a value plus k. K is the remainder here, and k is less than x. So k is less than x, and y modulo n will also be equal to k. So y equals to what? Y equals to n times b plus k. This is what you want. So if you look at it, what we actually want is this. Like if we open this equation, then we have this n into xa plus k. This was n into b, right? So some constant multiplied by this c plus k. This is what you want. So now if you look at it, we have xac, this is a multiple of this, plus this is a multiple of this k value, and plus we have this k. This is what you want, right? Y has to be this. So x is given, y is given. Then what do we need to determine? We need to determine a k for which this is valid, right? And if I have this k, then can I get my n value? Well, I can't get it directly. Let me write it here. We want n modulo x to be equal to n modulo x, is it? Yeah, n modulo x to be equals to y modulo n. Fine, and n can be as huge as you want, right? So if I am saying that n can be as huge as we want, then why can't I have n modulo x to be equal to y? Why can't I do this? So if y is less than x, then this is nothing. This is like n equals to x into 1 plus y, right? If we do this, I think we are done. So this is a case where y is greater than x. Yeah, and if y is equal to x, what do we do in that case? If y equals to x, then I can just print anything, right? Yeah. So let me just make some cases. If x is less than y, if x is less than y, or x is greater than y, if x is greater than y, then I have, do we have to print this n value? C out x plus y. Else if x equals to y, then I just simply C out x. Right, and for the other case, let's just for now print -1. Yeah, let's try out this. -1 is fine. 6 modulo 4 is 2, right? For 420 we can have it as 420 only. Yeah, that is fine. What about this one, 4 and 8? So it is saying that we can print 4 here. If you have 4 and 8, oh okay, so if y modulo x equals to 0, then I can just simply print x here. X modulo x will be 0, and y modulo x will also be 0, right? So that is fine. Also, both of them are even integers, so this is something to be taken care of, right? So here, if y modulo x equals to 0, then you simply see out x, right? Why? Because x modulo x will be 0 and y modulo x is already 0, right? Cool. Else, now we know that y is not a multiple of x. This is what we know, and we also know that y is greater than x, and y modulo x is not equal to 0. Also, what we know is that GCD of x comma y is at least greater than equal to 2. It is a multiple of 2, basically 2k, right? Yeah. So what do we do in this case? For example, if we had something like 6 comma 8, right? I think I can just write out some cases and try to find out some pattern if I get it. Let me just put it like 100 here. N equals to 1, n is less than equal to. So if n modulo x, n modulo I equals to j modulo n, then you see out right. Let's try to find out this. Also, we can just skip that case where so if j modulo I equals to 0, then I think we can continue in this case. We don't really need this case. So for 2, 7 we have 3. Okay, 3 modulo this is fine, and oh okay, for 2 comma 11 we have 5. For 2 comma 13 we have, and also like this is supposed to be, both of them are even, right? So I think I can find out some pattern here. 4, 6, 5, 4, 7, 10. Okay, so if both of them are even, then I can just take their mean, right? Would that be giving me the same answer? I think yes. I can take their mean, right? I can just print out x plus y by 2. See out x plus y. I think this should be fine. For 7 this is working, but like let's just see this case as well. I think if I just print the mean, that works totally. If you look at this one, then if I have 4 and 14, then I can just take the mean, which will be what? Which will be 9, right? So that will be giving me the same answer. But if I take their mean, then the thing is that this can be 0 as well, right? Like if I have x plus x plus x, if I have something like 4 comma let's say 12, so what would be their mean here? It would be 8, right? 5, 6, 7, 9, 10, 11. Yeah, so that would be 8, right? And if you look at 8, then you don't get the same answer. That is the issue here. Okay, so that is when does that happen? if y is less than 2 into x. If that is the case, then I can do this for sure. Right, even if I have something like 11 or in fact 10, then I have 7, right? So for 7 it works. X plus, okay, I cannot be having x and 3x. That does not work because 2x is the mean and that won't be giving me the same answer. So that does not work. But if y is less than 3x, then you do this, else what do you do? If y is less than 3x, let's just consider this case, what was happening exactly. If you have 4 and 12, we don't have 4 and 12. Oh, okay. But what about 4 and 14? So the mean here would be, it would be 9. So that works. And 4 and 18 we have no, so this does not work. If if y is greater than equal to 3x, this does not work. Then if y is less than 3x, then the thing is your overall value would be less than 2x, right? If it is less than 2x, then you have n modulo x and then you have this, so that is fine. If y is less than 3x, this is fine. If y is greater than 3x, what do we do in that case now? So let's just consider some cases again. So I have 4 and 26 where it is giving me 5. Or in fact, let's just consider 4 and 14. So 9 works here for sure, that is fine. But 9 doesn't work here because if you take the modulo, that would be 1. Right? So 9 does not work here. Okay. What else works? So we want n modulo x to be equal to y modulo n. And if I say that n is n equals to x plus k, y equals to n plus k, can I do this? So then I have y equals to x plus k, 2 into k plus n. And the thing here is that k has to be less than x. This is what you want. So if I just have 6 here, okay, no, but this is like n plus k, right? But I think if you look at all these numbers, these are pretty small. Like the answer is achievable in very small numbers. That is the thing here. Here it took like 16 steps. Both are even. Okay, let's consider some small cases here. If I have 4 and 22, so I'm getting 10. Okay, so x, it is like something like x into a, right? And then y equals to n times b plus k. So essentially what we're saying is y equals to x into a plus k times b plus k, right? xab plus kb plus k. This is what you want. B can be 1 as well. A can also be 1 as well. And k has to be less than x. This is what we want. And what we know is that y is greater than 3 into x, right? So what this means is that 3 into x is greater than y. Sorry, y is greater, right? So this 3 into, sorry, what you want is this xab plus kb plus k should be greater than 3 into x, and we want k has to be less than x, right? So if you look at it, we have kb plus k has to be greater than 3 into x minus x into a into b, right? So I have k into, okay, but b is common here, right, on both sides. If y is less than 3 into x, then this is fine. If y is greater than 3 into x, also like a and b, I have this, right? Okay, so y is equal to nb times k. So y is equal to xa plus k times b plus k, xab plus kb plus k. So I am saying that y is greater than 3x. So kb plus k is greater than 3x minus x into a into b, right? So obviously this a into b cannot be, yeah, this a into b cannot be what? It cannot be greater than 3. So for a and b, I can try out all possibilities, right? Yeah, I think I can do that, yeah. So okay, so how many test cases do we have here? Test cases are 10 to the power 5, so this is fine. Now what I'm saying is that, n is equal to x into a plus x into k, a plus k we want, right? So a and b are fixed. Now all I'm saying is that k into b plus k, in fact k into b plus 1 is equal to 3 into x minus x into a into b. Okay, so I just need to find out this x, sorry, k, and k is less than x, right? If you look at this number cannot be negative, right? So k into b plus 1 equals to this. Okay, x into 3ll. I mean, we already have our y, right? So y is fixed. Y is equals to this. Okay. RHS equals to xab if LHS minus RHS is greater than equal to 0 and LHS minus RHS modulo k equals to 0, then in this case my n equals to x into a plus modulo b plus 1, right? This was modulo b plus 1. Okay, so I'm trying out a and b here. LHS equals to y, RHS equals to x into a into b. Then I have kb in plus k. So I have k plus 1. Sorry, I have b plus 1 into k. So y minus xab divided by b plus 1 equals to k. This is what I'm saying. Okay. Now these are the three conditions that I'm checking. And LHS minus RHS divided by is less than x, right? In this case I am saying n equals to LHS minus RHS divided by b plus 1. So this is like k and I'm doing x into a plus. Okay. So I'm having 7 here. Let's try out very random cases and x equals to okay, so I need to check this n, right? N equals to x plus y. At the end I just print this n, right? So if n okay, so I just have to do this again. Okay, am I having an assert statement here? Assertion failed. So for this y modulo n, it is not working. Okay, Wasn't I already checking this? Okay, let's see. LHS equals to Y, RHS equals to XA into B. So I have XA plus K, right? Yeah, I have XA plus K into B plus K. So I'm doing XAB plus KB plus K. So I'm doing Y minus XAB divided by B plus 1. Right, this is what K is, right? And I also have to check if it is less than X. So what I'm doing is I'm checking LHS minus RHS is greater than or equal to 0. Then I'm checking LHS minus RHS modulo B plus 1 equals to 0. Then I'm also checking LHS minus RHS divided by X plus 1 divided by B plus 1. Oh, okay. So this had to be here, right? Modulo B equals to 0. Okay. So this is like XA into equals to, okay. Okay, so y is already greater than x. This is what you were saying, and y is greater than 3x, right? So this value is greater than 3x. So k into this is already greater than 3x. So what we are saying is k into b plus 1 is greater than this, right? Yeah. So this value, this cannot be negative, right? Okay, we have n modulo x equals to y modulo n. Then I'm saying n equals to xa plus k. I'm saying y equals to nb plus k. So y is equal to n times, which is xa plus k times b plus k. So I have this. Then I'm saying k equals to this, okay? Yeah. Then I'm also saying that k is less than x and y is greater than 3 into x. That is the condition. So this value is greater than 3 into x. Cool. Then we are also saying that k, oh, so it will always be greater. This is not like less, it will always be greater. But k has to be less than x. Okay. No, but this does not work. This is wrong. If y is greater than this, then k into b plus 1 has to be greater than this. So this value can be negative as well. Right? We have x into a into b. K just has to be a multiple of this value. Y minus this divided by b plus 1. I don't know, this is not working. got to get at least one more. If y is greater than 3x, what happens in that case? X times, and y is not a multiple of 3, that is the case here. So I will have y modulo x. If I consider this value and I just do n equals to y minus x, what about this one? Then I have n modulo x equals to y modulo x, right? And n modulo y equals to x modulo y. Minus x modulo y. N has to be between x and y, which is right. What if I have n equals to y minus k? Then I have n modulo x equals to y minus k modulo x, and y modulo n equals to just k minus k. So that is like n minus k. I have to find a multiple of x. Why can't I just find the biggest multiple of x? Oh, I think I can just do that. The biggest multiple of x which is less than y. Right? Oh, right. Multiple equals to y divided by, sorry, I have to find the biggest multiple of x such that it is less than y, right? Cool. So I'll just transform x here. So x will be what? X will be, since it is not a multiple, then x will be multiple into x, and I just simply print assertion failed again. Okay, this is to be x, y and n. This is the n that I'm getting. Y by x, okay, so this had to be, I don't understand what is this, like biggest multiple is y divided by x. That is the biggest multiple of x that I can get to near to y. If y is less than 3l into x, then this is already done, right? Biggest multiple is 6. Oh, okay, this one x1, okay, right. Biggest multiple of x which is less than y. This is what I'm saying. I don't understand what is the case here. N modulo x equals to y modulo n. Why does this not work? So I have this, right? N is equal to this. Oh, okay. I'm getting just one extra, okay. So if I take the mean value, am I taking their mean value? That is the question. Okay, I think this, just a minute. There was a condition that both of them are even, right? Yaar. Yeah, I think this should be fine now. Cool. This is fine. Let's submit this. Okay, great. The rank is not that great still, but okay. Let's read C. I'm having a -33 right now. But with that problem, I think I should be having... Okay, my rating is also 2061. And okay, I'm fine. But my rank is not that great. My rank is fine. Okay, let me try out C. Although if I would have done it a little earlier, then that would have been better. But still, let's try out C then.